Hi everyone, I am Vivek Chattopadhyay, Assistant Professor of Civil Engineering Department at Mollabhum Institute of Technology. So today I am going to explain you about the chlorination or disinfection. So before coming to the graph, I am explaining that what is chlorination and what is disinfection. So chlorination or disinfection is the process of adding chemicals or adding chlorine to the water to kill the harmful bacteria or to kill the pathogenic bacteria present in water. There are two terminology, one is chlorination and another one is sterilization. Now what is the difference between chlorination and sterilization? The difference is chlorination means that we are adding chlorine to the water to kill only the harmful bacteria, that means only the pathogenic bacteria. Another one, sterilization. Sterilization means that we are, it is basically a boiling process. That means in boiling process, both harmful and useful bacteria that can be killed. So the difference between the sterilization and chlorination is that chlorination means only about to kill the pathogenic bacteria. Whereas in case of sterilization, sterilization is not only the process of killing harmful bacteria, at the same time, simultaneously, useful bacteria that can be killed in this process. Now, disinfection is the last treatment process among the whole entire water treatment processes from intake to distribution unit. So, now coming to about this graph, this graph is known as the chlorination graph or chlorination curve. In this graph, you can see in the x-axis, I have written the chlorine added, and in the y-axis, I have written residual chlorine. Now, this x-axis denoted that how much chlorine we are adding. In the basis of that, the residual will be generated in the y-axis. Now, you can see the graph is flat in this OA zone. Why? Because in this zone, there are reducing agents that are present in this point. What are the reducing agents? Reducing agents are nothing but they are multivalent metallic cations of ferric Fe2+, or aluminium Al3+, or magnesium Mn2+. So these are the reducing agents that are present in this OA zone. That is the reason that the chlorine gets consumed in this region, and that's why the graph has not started from its origin. This point is to be noted that the graph has not started from its origin. Why? Because of this reducing agent, the chlorine gets consumed. And in this AB zone, you can see the graph is in increasing manner. Why? All the formations of HOCl means hypochlorous acid, as well as chloramine NHCl2, this is dichloramine actually. So all of this formation, that means chlorine reacts with water and it forms HOCl. At the same time, chlorine reacts with ammonia and form NHCl2. So these formations are happening in this AB zone. That is why the graph is in increasing manner. And in the BC zone, what happened? Destruction of microorganisms or destruction of chloroorganics are happening here. In this AB zone, the demand is so high. As the demand is so high, that is the reason that the graph is in increasing manner. And in the BC zone, you can see that the graph is in decreasing manner. Why the graph is in decreasing manner? Because in the BC zone, destruction of chloroorganics are happening here. Microorganisms are killing of the microorganisms or killing of the pathogenic microorganisms are happening in this BC zone. That is why bad smell starts from here and bad smell ended here. This point is very crucial point. This point is known as the breakpoint. Breakpoint means what? What is the significance of breakpoint? Breakpoint means that after this zone, chlorine is not reactive. That means after breakpoint, chlorine further doesn't react with water and doesn't form HOCl. You can see that in this zone from O to C dash, in this zone chlorine is reactive, but after breakpoint or beyond breakpoint, chlorine is not reactive. in this zone what happens, that when chlorine reacts with water, it doesn't make any compound, and that's why how much we are adding chlorine, that same amount of residual will be generated in this zone. It means if we suppose we are adding X amount of chlorine, X amount of residual will be generated, because chlorine is not further reactive. So, and here this point is to be noted, that residual chlorine should not be more than 0.2 milligram per liter. If it should not be more than, it should not be more than 0.2 milligram per liter. That means it should be less than 0.2 milligram per liter. And if the residual chlorine, the concentration of the residual chlorine is more than 0.2 milligram per liter, so bad smell will be, bitter taste will be generated. And this is the main thing, whole demand of chlorine. Demand of chlorine equal to dosage of chlorine, that means chlorine dosage plus residual. This is the main thing, that whole demand, chlorine demand equal to dosage of chlorine plus residual. Now talking to point about the break point, what will be the equation? Break point residual will be 0. That means demand of chlorine will be equal to dosage. So this is the graph. This is the brief discussion about the chlorination graph, and we will explain the more topics in the later days. Thank you so much for watching. Thank you.